All right, everybody, this is going to be a video about slope and how to find the slope if we only know 2 points on the line. Forgive my technology setup here. It's not as fancy as it usually is. I'm having issues with my document camera. You should see what I have set up here. It's pretty hilarious, but you can see like random things on my floor. I think that's like a hand sanitizer. Okay, so what we're here to do is we're here to find the slope between 2 points. And the 2 points I'm going to use in this example for this video are the points 3, 5, and 7, 15. As we know, slope is a measure of steepness. We also know that slope is something that we have been calling growth. The growth, so like think of those tile patterns when it like grows by 2 boxes, right? So the slope of the line would be up 2 over 1. You grow 2 in the y's every time you grow 1 in the x's. So we're going to kind of remove this context, and we're just going to talk about lines and the pure math. And when we do that, we call it the slope. And we'll go back to connecting to the real world after we do some work here. So there's 3 methods that I can think of. There's actually a lot more ways to think of this, but for this video, there's 3 methods. And method number one is graphing. And this is similar to what we've been doing in class. So we're going to graph it. And here's how we're going to do that. I'm going to get my graph paper. I'm going to set up an XY axis and plot the points 3, 5, and 7, 15. And I know those are in quadrant 1, so I'm only drawing a quadrant 1 graph. Here's my x-axis, here's my y-axis. I'm going to plot my first point of 3, 5. So 3, 5. My second point of 7, 15. 6, 7. 6, 7. Ooh, did I give myself enough room? 11, 12, 13, 14, 15. I did. Yay. All right. I always screw this up. 7, 15. I think it's there. I'm going to double check. 7, 15. Yep. And if I wanted to, I could, like draw the line that goes through those points just for a visual. Well, I kind of messed it up, but that's okay. All right. So now to find the slope between these 2 points, we use, it's commonly M is what we used for that slope. Slope is the M. One thing that you've been learning about that's really popular in algebra classes is to call that the rise over run. And that relates to these growth triangles or slope triangles that we can draw between 2 points on a line. You can draw the triangle above the line or below the line. It doesn't matter. I, for some reason, usually just draw it above the line. It's just my habit. So when we are looking for that slope, it's going to be a fraction. It's going to be this ratio of the vertical distance here between the 2 points and the horizontal distance between the 2 points. And once we start talking about the table, I hope you start realizing why it is that way. But let's just start here. So we're going to look for the height. This here. What is this distance here? I find that by looking back at the y-axis. And then I think about the distance between these 2 numbers, the distance between 5 and 15, which is 10. And I can find that by thinking about 15 minus 5. 15 minus 5 is what gives me that 10. I'm not talking about this 10. I'm literally talking about the distance between 15 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the height here of this triangle is 10. It's not 15, it's 10. All right, now I look for the horizontal length here. So again, I do that by going down, looking at the x-axis. And whatever this is here, it's going to match up with this width here. So 3 to 7 is 4. And I can check that because 7 minus 3 is 4, right? So subtracting 2 numbers tells you what the distance between those 2 numbers are. So that's going to be a 4. So now I can go and I can write my slope. right? We call that M. M equals slope. So I always do the rise, that vertical, that change in Y is sometimes what it's called, the change in Y. Let's see if I can lower my camera down just a little bit to zoom in. Ooh, that's nice. That's better. So that change in Y, that rise, that vertical change is 10. And then that run, that horizontal change, is the change in X, right? This is delta. That means change. So the change in X is 4. Now I can reduce that fraction. I can simplify it. I can either do that with those elementary school skills of reducing fractions, or I can just take out my calculator and divide 10 divided by 4. I'm going to do both. So 10 fourths reduces to 5 halves. And then if I plug either of those into a calculator, I get 2.5. And that's the unit rate right there. 2.5 divided by 1, but it's 2.5 is the same. So my growth is going to be 2.5, meaning I go up 2.5 every time I go over 1. I go up 2.5 when I go over 1. I go up 2.5 over 1, up 2.5 over 1. My line's a little deceiving. So that is how we find the slope on a graph between 2 points. The second method would be to think about the table. Now, here's the thing. I'm not going to put my points right next to each other. I'm going to space them out 3 to 7 because I want to keep track in my brain that I'm thinking about the distance between this point and this point, just as we did on the graph. So what I want you to do is keep this in mind while we do the table example. So I'm going to even just like kind of let that hang out over here. There we go. We'll let you hang out so we can keep you in our minds. So again, I'm looking at the change in the Y's and the change in the X's. So quite simply, what I can do is think, all right, well, from 5 to 15, I'm going to add 10. And from 3 to 7, I'm going to add 4. Ooh, let me do green because that's what I did in the last one. And so the slope is that change in Y, the rise, over the change in X, positive 4. And there I have it. And when I reduce 5 over 2, or 2.5 over 1, what that gives me is now the growth in between. So that 2.5, check this out. If I just want to move 1 along the x's instead of 4, I'm going to add 2.5, which is the same as 10 over 4. I'm going to add that to 5. And I'm going to get 7.5. I'm going to add it again, and I get 10. I'm going to add it again, and I get 12.5. If I add it a fourth time, I get 15. So it works. That growth of 2.5 4 times adds to my 10. And that's the connection to how these are related. Now that's trippy. That's trippy to think about. Like, whoa, it works. This is how numbers work. It's crazy. All right. So, again, you can hopefully see how thinking about it in a table relates directly to how we thought about it visually on the graph. I think this is easier because it gives us this picture to deal with. But this is almost like quicker and more efficient. Not all this in between, but just figuring out that 10 and 4 piece, right? And so that kind of leads me to method number 3, which is the algorithm, the formula, the procedure that's commonly taught in an algebra class. And it connects all to this. And here it is. And this is the quickest way to do it, to find slope, but it's also the easiest way to make mistakes. What we do is we think about this being an x and this being an x, and then this being a y and this being a y. And what I have to do is think, all right, well, what's the distance between 5 to 15? Well, I get that by taking 15 and subtracting 5, and I get 10. And then, all right, 3 to 7. What is 7 minus 3? It's 4. Well, then I know that slope would be to take those two numbers and divide them. So my slope is 10 over 4. The reason I don't like jumping straight to the formula is because it's without the conceptual understanding. Like, we have to know what we're looking for and visualize it in order for this to make sense. This doesn't make sense if we just go straight to this without this. If I just taught you the formula, it wouldn't make sense. Like, why is she doing that? It doesn't, what is she looking for? Blah, right? So we have to build up this understanding. Yeah. Oh, and then the other reason I don't like the formula is that this is a mistake that I see all the time. It's my favorite mistake. I even have calculus students that do this. They go like this. All right, 15 minus 5 over 3 minus 7. I'd get 10 over negative 4. The slope is negative 2.5. Wrong. And what they did is, in the second one, they thought, oh, 3 minus 7. Or sometimes they go 5 minus 15 instead of 15 minus 5. So it's important that if you do the algorithm, the procedural way, the formula way, you just keep track of which way you're subtracting, and you do it consistently, and then always check your answer by plotting the 2 points on Desmos. Plot the 2 points on Desmos. And if they create a positive slope and your answer is negative, you know you did something wrong. All right, there's your video on slope, folks.